આગળ વધીએ હવે. ઓકે, ચાલો. Now we can understand the second part, electric current in a conductor. There is a second part, electric current in a conductor. Electric current in a conductor. What does it mean? First of all, try to understand what do you mean by conductor. What do you mean by conductor? The conductor in which there is a free electron. There is a free electron. It is named as a conductor. The conductor is in which there is a free electron, free to move. As we see that every object have electron, just like this page have an electron, this pen have electron, our body have an electron, the wire have an electron, there is a plastic, there is a wood, everything that is a conductor would have also an electron, free electron, but it does not have free electron. If the object have free electron, then it is named as a conductor, because due to with the help of this free electron, electric current is moving from one point to another point, from one point to another point according to potential difference. But if the object does not have free electron, just like plastic, just like wood, then you give the potential difference, but there is no free electron, so no motion takes place of any electron and no current flow from this conductor, no current flow from that object. So it is named as an insulator. Now, in this theory, we can understand focus point is electric current in a conductor. How this electric current in a conductor it behaves? It behaves. See, first of all, I would like to draw the conductor here. I would like to draw a conductor here. This is the simple conductor with electric field, also with potential difference and without potential difference. There is the conductor, there is a cross sectional, there is another cross sectional, here is cross sectional, just like this way, right? There is a positive charge placed at the lattice point. Always there is a positive charge placed at the lattice point. Now, in very first case, there is first case no potential difference, no potential difference over here. If no potential difference means random motion of an electron, random motion of an electron. You see, there is the random motion of an electron takes place, random motion of an electron, no potential difference is there. And if there is an potential difference applied between two ends of the conductor, there is a particular direction of motion of electron takes place. Now, try to understand this scenario. What is this? Every matter is made up of atom and molecules. So as we write down over here, every matter is made up of made up of atoms and molecules. Atoms and molecules. Every matter is made up of atoms and molecules. These atoms have free electrons, or say valence electron. These atom have valence electrons, and are these valence electrons and these valence electrons are bound with these valence electrons are bound with outer orbit with nucleus. These valence electrons are outer orbit with nucleus, bound to with nucleus. If small amount of energy provided to this electron try to free. This electron try to free, and these electron move in a conductor freely, just like this way. It does not come outside of this conductor because, and it only and only move on the surface of a conductor if you provide little amount of energy. This little amount of energy is from room temperature. This little amount of energy, it is gained from room temperature. So at room temperature, this electron, or say valence electron gain energy and free from valence orbit and only move on the surface of a conductor, and they move only surface of a conductor, only move on the surface of a conductor. Means these behave like a free electron, means this electron behaves like free electron, not like, it is a free electron, almost free electron, not a behave, it is almost a free electron, not a behave, it is a free electron. This means electron, not a behave, it likes, not likes, it is free electron. This electron is named as free electron. Electron is named as free electron. With the help of this free electron, an object named as conductor, and if there is no free electron, that object is named as insulator. This object is named as insulator. Now the meaningful diagram is what? First number, that is first number diagram. In diagram 1, you see this. In diagram 1, there are free electrons are moving. Free electrons are moving randomly on the surface surface of a conductor. These free electrons are moved randomly on the surface of conductor. You see properly, on the surface of conductor, these electrons are moved randomly. You see properly, because there is a valence electron. This electron does not come outside on this surface, only they remain in this surface. If this electron gain some extra energy, that energy, it may be in terms of radiation, in terms of temperature, in terms of anything else, so that electron come outside of the surface of this system, Now move further. Now apply potential difference to this. Now apply potential difference to it. Then what happened? Potential difference in terms of a battery. Clear? In terms of battery. So here apply potential difference. So this is the positive terminal, that is the negative terminal, and you apply the battery over here. So that is the positive term, that's the negative terminal. And electron's motion is from negative to positive side. Electrons are moving from negative to positive side. So that is the negative electron, that is the negative electron. Motion is along this motion is along positive direction. Means every electron is aligned themselves to move towards the positive direction. Every electrons align themselves to move in the positive direction. What to understand? Now battery is connected to the conductor. Initially, there is no battery connected. So in any cross section area, initially there is no battery is connected. So in any cross section area, the electron moves random motion in any cross section area. Means number of electrons moves from left to right. That same amount of electron moves from right to left, left to right, left to right. That is an equal proportion. Equal proportion in the direction is equal to the number of electrons crossing through the cross section of a conductor in opposite direction. Means left to right and right to left. Number of electrons are same. Number of electrons motions are same. So there is no current is properly gained from the random motion of electron. No current gained from random motion of this electron. As it is, you see electrons are bound to the surface, so no current is from that. In any cross section area, number of electron moves from left to right and right to left, both are same, so total goes to 0, means no current is there. If the battery is connected, means potential difference is applied to two ends of a conductor. Right, now apply potential difference. Potential of a conductor. Two ends of a conductor means apply battery. Means apply battery. The apply battery to the two end of the conductor. Battery you apply like this way. So what happened? What happened? You see what you now. As we apply the battery, means potential difference between two ends of the conductor, electric field is established. Electric field is established from positive terminal to negative terminal, from positive terminal to negative terminal, By this way, electron is moving opposite to electric field. By this, electrons are moving from negative side, or say negative terminal to positive terminal, or opposite to electric field, or opposite to electric field. That is the key point, or opposite to electric field. By application of some external electric field, that is an external electric field by application of a battery, not a external, it is by application of a battery, one can establish the electric field from positive to negative direction, and by this way every electron is attract opposite to the electric field. So motion is aligned only one direction. Motion is aligned only one direction. By equation, vector F is equal to minus QE. Every electron affects this force. Every electron experiences this kind of force. You can see this is the main equation. F is equal to minus QE, electric field direction, force direction. You see with they are opposite because there is a negative charge. Due to this electric field, free electrons are moving from negative to positive terminal of the conductor due to this equation. So this battery is connected across the two ends of the conductor, provides the steady current into the conductor. This battery provides steady current into a conductor. This provides a steady current into a conductor. So this is the electric current in a conductor. By this way, with the help of this equation, one can understand properly that due to this electric field, negative charge particle is motion. Charge particle is motion opposite to electric field. So force and electric field both are opposite due to this negative sign. Due to this negative sign, both electric field and electric field and force are opposite. Okay. Now this is first. Once again, you see this that electric current in a conductor. Now, as these electrons are moving in every cross section area, as this every electron moving through any cross section area in a same interval of time, same charge particle is moving, but there is the drifting of electrons takes place with the help of this equation, drifting. So you move towards the drift velocity, drifting takes place, so you move towards the drift velocity. What is the drift velocity? You see, move towards the drift because of there is a drift velocity. The word is that drift velocity. What is the meaning of drift velocity? Drift of electron takes place. Okay, how it is that? When electric field is applied, any cross section or across the conductor, as battery is applied, such that electric field is established into conductor. Battery applied, electric field is applied, so established in the conductor. So free electron now accelerate. So free electrons are accelerates and move, or say, and motion is opposite to, and motion is opposite to the electric field. Motion is opposite to the electric. Okay, motion is opposite to electric field. Okay, now due to this acceleration, it gains extra velocity. Due to this acceleration, what does interesting fact over here? Due to this acceleration, it gains extra energy. It gains extra energy. But what happened? Here? By this acceleration, these electrons are immediately collide with that positive charge which is reside at the lattice point. By this acceleration, these electrons immediately collide with positive charge. Immediately collide with positive charge. What to understand? is reside at lattice point, at lattice point. What to understand? It is a word that positive charge is reside at the lattice point, and this free electron is immediately collide with it. So what happened? So that electron lose its energy. That electron lose its energy. So that electron lose its energy, lose its energy, everything, and lose its energy. And what happened? Convert and become a stationary. Become a stationary. Okay, and become a stationary. Lose its energy and become it stationary. Okay. Again, it gains energy from electric field. Again, it gains its energy from electric field. From electric field. Again, it gains energy from electric field. Electric field, and again accelerate. And again accelerate, and again collide. Again collide, and again lose its energy. Again lose its energy, and this process continues. And this process continues. So step by step, collide, lose energy, again gain energy from electric field, again drifting. Means every time drifting takes place. This is the drifting. This is the drifting in opposite to the applied field. This is drifting. Drifting of electron opposite to external electric field. External electric field. It is a drifting of electron. Again and again, same process lasts long. So drift velocity is the average velocity. Drift velocity is the average velocity. So one can understand drift velocity is average velocity with which free electrons in a conductor gets drifted in the opposite direction of the applied electric field. Drift velocity is an average velocity, with which free electron, what to understand, free electrons gains energy from electric field and motion or moves opposite to the electric field. Moves opposite to the electric field. Now, what is the equation behind it? So move towards the equation. So first of all, force vector direction F is equal to minus Q into E. That is the force. F is equal to minus Q into E. Equation number 1. As we know that there is an acceleration produced in electron. So acceleration is produced due to electric field. Is F is equal to ma. That is the second equation. Acceleration is produced. So by comparing these force, 1 is equal to 2. 1 is equal to external, that is an electric field. There is electric force. There is a negative charge. Force on negative charge. Due to this electric field, acceleration takes place. that acceleration is equal to F is equal to ma. By comparing these two, you see minus QE is equal to m into a. Therefore, a is equal to minus QE upon m. That minus QE upon m, that is an acceleration equation. Now, this acceleration is in a very short time. This acceleration is in a very short time. You see that name is number 3. This acceleration is in a very short time. In a very short time. And what we say again goes to 0, again gains energy from electric field, again abruptly collide, and again acceleration goes to 0. So this acceleration is lasted so much very small time. Within this small time, the distance it cover, small amount of distance it cover, that distance has some meaning, and that small time is named as relaxation time between two successive collision. This short time between two successive collision, this short time between two successive collision is named as relaxation time. Is named as relaxation time. What is that relaxation time? Meaning is that relaxation time between means in between these two collision, electron is totally in relaxed mode. Between two collision, suppose that is a positive charge, electron is collide and move from here to here. In between these two, electron is completely relaxed. Therefore, this time is named as relaxation time, and it is denoted by this way. This is denoted by this way. By equation point of view, one can understand how one can understand this. So from equation of motion, you see V is equal to V0 plus AT. That is a vector notation. That is a vector because everything is in vector. Now, what happened? As you see, this velocity is named as drifting velocity. Initial velocity goes to 0 because starts from rest, acceleration A, and this is tau because tau is the relaxation time. This tau is a relaxation time. Initial velocity is 0, final velocity is converted to drift velocity. Get it? Now, as you see that value of A, we have value of A, which is nothing but minus QE upon M in a vector notation, and there is a relaxation time. This equation is named as drift velocity, is equation of drift velocity. This equation is in this drift velocity. You see that drift velocity is in opposite to the electric field. This drift velocity is opposite to the electric field. You see, this is the opposite to electric field. Due to negative sign, this drift velocity and electric field both are opposite direction. You see properly, opposite direction. And if you magnitude takes both the side, so that is the QE divided by M into tau is there, QE divided by M into tau is there. So that is the equation of drift velocity. That is the equation of drift velocity, right? Okay, stop kar दें.